ABCD is a quadrilateral in which PQRS are midpoint of the sides AB, BC, CD and DA. AC is a diagonal, show that SR is parallel to AC, SR is half of AC, and PQ is equals to SR and PQRS is a parallelogram. So before starting this exercise, let me tell you this exercise is mostly based on midpoint theorem. Midpoint theorem says that in a triangle, if we have a triangle and if midpoint of one side and midpoint of any other side is joined together, then the line formed will be parallel to the third side of the triangle and vice versa. So let's carry on with our question, and most of the question you will find that are based on the definitions only. Like this question, we have a triangle. Let's consider a triangle A, C and D. In this we have the midpoint SR, S and R of the line AD and DC. Since these two midpoints are joined together and by midpoint theorem the SR will be parallel to AC, and also midpoint theorem says that also that after joining that midpoint that this length would be half of this length. Okay, that means if this is SR in our case and this is AC in our case, so SR is equals to half of AC. This is what midpoint theorem says. So by the definition of midpoint theorem, SR is parallel to AC because two midpoints are joined together and their line formed by these two midpoints is parallel to the other side. And another property or the another condition of midpoint theorem says that this line SR is half of AC. So this part is done just by definition. Similarly, in triangle A, B and C, AC is parallel to PQ because P and Q are the midpoint of side AB and BC. So lines formed by joining these two midpoints will be parallel to AC, and similarly this PQ will also be half of AC. Since both are half of AC, SR and PQ are equal, and this line is SR is parallel to AC and AC is parallel to PQ. Therefore, SR is also parallel to PQ. So we get that SR is parallel to PQ and also equal to PQ. So by using parallel theorem of parallelogram, opposite sides are equal and parallel in a quadrilateral SPQR. Hence, it is a parallelogram.